Okay, here's another example of trying to show that lines are parallel. We're no longer showing that angles have certain relationships. We've adjusted a little bit and we're working backwards. So I'm going to tell you something about angles and you're going to try and show me that the lines are parallel. In this case, what we're trying to do is show that if the same side interior angles are supplementary, so in the picture, an example would be 3 and 6 are supplementary, we want to say that's enough to say the main lines here are parallel. Again, so far we've assumed corresponding angles postulate. We have proven the alternate interior angles version of this. For this example, I'm going to say we have to again use corresponding angles postulate. So what we're trying to do is based on only starting with the fact that 3 and 6 are supplementary, so only knowing that 3 and 6, they add up to 180. So I'm going to do this. A lot of times I've been doing that to say, hey, they're congruent. In this case, they add up to 180. What I want to try and show is that that's enough to say that the lines are parallel. So again, let's talk game plan here. When we talk about supplementary angles, that generally means at some point we're going to use the congruent supplements theorem just based on past history. But we also need to have a way of tying in corresponding angles. So we're going to try and show, ideally, that 1 and 5 have to be the same, or 4 and 8, or 2 and 6, or 3 and 7. That's our goal, is to show that those pairs are the same, because if those pairs are the same, that implies the lines have to be parallel. So let's just try and connect angle 3 maybe to a different angle. Now we could say that 3 and 1 are the same because they're vertical, but it doesn't really give us a corresponding angles relationship. We could say that 3 and 4 are the same, or are supplementary, but again, that doesn't really connect with angle 6 in the way of corresponding angles. Or we could also talk about 3 and 2 being supplementary, a linear pair, and I like that idea because if I can show that these two are supplementary, okay, you need to ask yourself then, do I have a connection with 6 and 2? What can I say about 6 and 2? And they look like they're the same, so we have to start thinking, well, if I know that 3 and 6 are supplementary, and I know that 3 and 2 are supplementary, how can I say then that 2 and 6 have to be the same? That's got to be a bit of our game plan here. Okay, so let me just kind of walk you through how I would start this. Okay, we start by writing the given, so angle 3 and angle 6 are supplementary. Okay, that was the given. It's a sloppy G there, but that's supposed to be a G. Okay, I want to say that angle 2 and angle 3 are supplementary, and that's because they are a linear pair, so the linear pairs postulate. Okay, now here's where you need to be thinking about what we've done in the past. In the past, if we saw these two statements, 3 and 6 are supplementary, 2 and 3 are supplementary, these pairs have angle 3 in common, we need to start thinking about, well, how do I know that these two then have to be the same? I think intuitively it makes sense, but what's the reason behind saying that those two have to be the same? Okay, we'd like to say, we can just substitute them back and forth, but when we're talking about supplementary angles, the reasoning that we use is that congruent supplements theorem, and if you have not looked that up and we keep using it over and over again, you really need to go to your term sheet or to the proof that we did in class a while back. Look it over, look at the pictures, and start figuring out why together lines 1 and 2 imply line 3. And if that's not working, ask a question at some point. Okay, and now remember, these proofs are a little different because at the end we're trying to show that the lines are parallel. Well, I now have a way of showing that angle 2 and 6 are the same. 2 and 6 are corresponding angles. And if corresponding angles are the same, these lines have to be parallel. Okay, so we're using that corresponding angle postulate kind of backwards from what we did before. But because of this, I can say this, and there's why. That's kind of how these types of proofs will end almost every time. Okay, we'll stop right there.